Welcome everybody to this webinar from IVRPA. We have really, I think, a very exciting and slightly scary presentation today having to do with AI and how it specifically will interact with our creative professions. That will be led by Lauren Ibarrando, one of our esteemed board members who is exceedingly versed on these issues of late. I want to let everybody know that this is being recorded. It will be available on our website to paid members. So you can watch it again, which I'm sure a lot of us will want to do because it will be packed with information. If you are wanting to put something into chat, you'll notice just above the chat dialog window, it says who you are sending it to. If you want everybody to see it, make sure that you click on everybody. Otherwise, it'll go just to the panelists or just a particular person. Let's see. I am going to pop up a quick survey here. And the question would be, has to do with, is Saturday still the best day to hold these webinars? I'm asking the live group here to put in their votes, and we'll probably also send this out to the general community. Most other professional organizations have their webinars during the week. For a number of reasons, we had decided it would be better to try Saturdays, but let's see what people generally think. Let's see, what else? I think that's all I can. Oh, all right. Who is IVRPA? IVRPA, the International VR Professionals Association, is the only international organization which is dedicated to the needs or interests of the VR and XR creative people, as opposed to corporations or the real technical aspects. We focus on the creatives. And we primarily are an educational organization. Our objective is to help our members and the community in general be more successful, both in the work that they do and in their business, their livelihood. And one example is the webinars that we put on, which will have a different take than you can find in other aspects, and very often will present information that you cannot really easily get anywhere else, at least exactly what we are presenting. And I find from that standpoint, it's a very valuable organization to belong to. If you aren't currently a member, I encourage you to consider becoming a member. The cost is obscenely small. It's only $50 per year. And considering the value you get from that, I think it is really worthwhile. Let's see. After Lauren's presentation, we'll have it open for questions. If you want, ask questions, probably in the chat. We'll try to pay attention to them if it comes up that it's useful to answer during the presentation. Otherwise, everything is available at the end of the presentation to talk about this presentation or anything else you want to having to do with XR or IVRPA. With that, I will take my exit and turn over to Lauren. Lauren, take it away.
All right, thank you, Scott. And I'm going to go ahead and if everybody can see me. I don't see them popping up yet, but okay, there I am. Good. All right, I'm going to go ahead and get started. Like I said, I'm a board member here, and I'm going to give a presentation today on the intersection between XR and artificial intelligence. I'm not going to try to teach you artificial intelligence. It's a vast. In fact, I'm going to try to stay away from the technical aspects as much as possible. And I think that's possible with this group because we already understand a lot of the mathematics, workflows, and procedures that we're going to be dealing with. So I'm going to go ahead and just get started into it. I wanted to point out that I've dropped a PDF of this presentation in the chat, It has a lot of links in it. And for example, this first one on the front page, I won't click on it, but the image that you see of the face is actually not AI, but old school ray traced and volumetric rendering. And it came from a project quite some time ago looking at the integration of JavaScript and imagery and starting to create graphical user interfaces. It's from maybe the 1995, 96. So it's very similar to this subject. The rabbit I put here is because as I worked on this for about a month surveying AI, it really is a rabbit hole. It really is Alice in Wonderland, and there's some good and some bad aspects to it. So as we go through this and you're learning this, remember that it's just a communication tool. So it's how you use the tool that's good or bad, not the tool itself. And this is a very powerful tool. Oh, I'm seeing a quote pop up here. Okay. What I'm going to be covering today is, again, just a survey of trends and tools. I'm going to cover a little bit of education, trying to bridge on what we already understand from sensors and image processing, and then advancing into the more technical things that you're familiar with already, the generative fill that you're using in Photoshop, or if you've played with Firefly. And then I'll extend that from the flat into our world, into immersive. Now I say XR, but I'm going to be doing a lot of the examples will be virtual reality, but I'll try, because we want to grow the group here, I'll try to reference when possible augmented reality applications. Or if it's 360 video, of course, it's just the frames that I'll be talking about moving. And I invite people in the question and answer in the chat. If I say something and you've got some good links, you know a little bit more about it, I say something wrong, please let me know, because this is not my area of expertise. And as you will see here in the next slide, it's a very big area of work. We'll look at the chat GPT, the analysis, talking to something, having it give you ideas on designs, maybe interface colors, things like that. I'll look a little bit about that. Then it's coding assistance. If you're doing any HTML, if you're producing any of your websites, or you're interested in using some of the less friendly programs, how can it produce code for you? How can it help you? And then we'll look into the actual, what they call text to apps, where you're building mobile applications and other things by just talking, same as we have the text to speech. So I'm going to keep through this, keep trying to build upon knowledge and dispel the mystery of this. At the end of, hopefully you understand, this is not a magical thing. It's really quite simple, mostly linear algebra and matrix mathematics and a data center doing all the work for you. So on to the next slide here. So this is kind of a diagram of the ecosystem, or the process where we're at. We typically find ourselves over here, camera sensors and things, the devices, and we end up with light bouncing off of objects. I have it going towards the eyes of a robot, but if that was us, that's how we see, is light reflecting off. The light rays come in through some type of a lens and focused onto a sensor, and you have the RGB sensor. And I'm going to use the metaphor of a tree. That'll be important because of the shape, and how we're going to start talking more than just RGB and transparency values. We'll start adding in more information. But even though we add in more information, it doesn't change the nature, the complexity. It's just stacking things upon each other. And so when we take a photo, when we collect that voltage data and it ends up over as a matrix, there's some magic that occurs, right? Some processes where they take that voltage, whether it's Nikon or Canon or Sony, and they have these mathematics that take that data that they've collected off the sensor, and it turns it into eventually a pixel, another matrix, another grid that it's holding. And the neural networks that we'll talk about here in a second, they overlap with a lot of that image processing and pattern recognition. When your phone started to be able to see people's faces, the early things was it was finding a round circle with two more round circles in it. And so that whole area is not necessarily, well, it's within artificial intelligence. So if you go down, artificial intelligence encompasses within it machine learning, but there's also data analysis or big data or pattern recognition, things like that. Within machine learning, which is where you're starting to train something, it's you can think of some of the icons that are there on diagram here. Think of connections and tools, mechanisms that you're starting to build. And if you go down further into deep learning, which is a subset of machine learning, you're talking about DNA or fingerprints or the individual connections between something. So individual components. And we're going to spend a lot of time in, well, not a lot of time, but we're going to spend some time in that. And then neural networks, think of neural networks as that, like right now, the example I'm using is a sensor with, let's say it's an 8K sensor, right? So it has 8,000 dots or pixels in the final image, and I'm recording a red, green, blue value and a transparency, an alpha value. But as I start to build out that matrix, start to go up and up with it, I end up with something that starts to approach starts to be modeling the look of our brain, where there are neural networks, where the connections are not just one to one. And as you're learning this, and at the lower, there's a link at the lower right of the slide, which goes to YouTube, has a lot of good videos about the entire process, kind of going through if you want to learn how this mathematic works. But really, that those connections that we had, where one thing is connected to multiple other data points, and so maybe it's the camera sensor, that individual sensor now is reaching out and has relations to maybe 3 or 4,000 of the other sensors around it, and it starts to measure how much is flowing over onto them, or what's the difference between the colors. So it starts to, all of these patterns, all of these recognitions, all this data, we just keep collecting more and more, but it still is stored in a matrix. The mathematics that are done on these to, like if it's like the codecs from when we're compressing things and we're trying to go from a raw image to a JPEG, and we're interested now in, if it's an opaque area, we want to know all the pixels in that area that are approximately the same color, and we start to write all of that. Let's think of that as a black box or a secret sauce. And if you wanted to get down into neural networks and learn about it, then you'd be into the mathematics. But if you don't really have to worry about the mathematics. I just assume that it works, and let's build now on what we know from cameras of just taking a picture, coming onto a flat sensor, the tree, and let's add in another aspect here, which is the pattern recognition, and using this concept of when you see a tree, how do you know that it's a tree? It's because you've been raised and you've seen tons and tons of trees, and that maybe from a distance, as you first start to see the tree and it's blurry or something, you primarily see the color. Usually it's going to be a greenish color on top with a more brownish color underneath. The thing on top is going to be ovalish. The trunk is going to be approximating a rectangle. So that's a pattern. And then if I combine that pattern with the colors, that's a way in which, if in the distance you just barely see some blurry dot, and as you get closer, before it's actually in focus, you start to recognize that it's a tree because of the patterns, the colors. There might be other things as well, other conditions. It's summer, or you're not in a desert. So if you're in a desert and you see that, you're wondering, well, wait a second, that must be a windmill or something else. So all of these pieces of information allow you to predict or to eventually tell what something is. So how would this, when you are on generative fill, or you type something into to Firefly, and you type something in like make a lush forest, how does it know? How does it start? Where does it, how does it pull together? And it's really kind of, I think, kind of simple. And I've really, of course, really simplified this down so we can try to understand it, and boiling it down into the very simple. But you start with, okay, you type this in, make a lush forest, and the model has been trained. It understands that lush means green, and it knows that forest will have other aspects, but it's going to include this shape. It's going to have a bunch of these patterns in it. So you'll hear of training models and supervised learning and unsupervised learning in AI. What they're doing is they have, let's start on the right hand side here. They've gone and taken every picture because they know that a forest will have a tree or they want a tree, but they know that a tree, bush, plants, it'll have all this stuff in it. So they fed it every photo of a forest and parts of forest they've ever had. Let's just take three of these that are pretty similar but let's take now and run to the left and blur them all the way down to the point that they become just one pixel, one color, one of these values we're after. And now we're going to start with again, not just three, but an entire data center filled with millions of these things. But let's look at the three right here to start with. You hit return, it jumps now out of this data set that it has, the model, and it looks for, boom, it's going to go with color because it has no forms, there's no shapes recognizable, and it goes with the color. So it starts in the middle there with that green. That's lush, good to go. It starts marching along, and there's a weight. I've drawn straight lines, but it would be more of a searching pattern. And there's how much does green matter versus the shape, things like that. So it kind of drifts its way over towards, it's been told that that shape is more important than green because trees come in all different kinds of colors. So first time it sees that recognizable pattern of a tree, it pops over to that, and it's going to follow this line of images down until it gets to the end, until it goes along and it sees another. Oh, here's another pattern. So I got two patterns, but this one it's back to the lush. So that's the choice it goes with now. It starts to go down and it finds, another pattern and it checks it. It's not quite as lush or green, so it works its way down and it ends up with the final tree. And that's, if you can understand that or just appreciate that simple process now scaled up with data centers. So maybe now you're looking for the ground as a second object, rectangular, that may be if the round object at the top has, a certain type of an edge to it, which is typical of leaves, then that's more of a leaf. That pattern, how does it know it's not a lollipop, a stop sign, or a forest? It's got ways. So these models that you're dealing with, ChatGPT, the other ones, or the image makers, Dolly and those, that's essentially how they're doing that. And I've included the links to some of the main ones here that you can click on and go to. I tried to, where possible, include the free ones and did put on the subscriptions. Because one thing about this AI is it seems like I'm going to pick up like there was the cell phone, and then I had to get cable TV, and then now I'm going to have to have an AI subscription. I just know it. It's going to be I got water, gas, electricity. I'm going to have an AI bill. So I didn't want to sign up for anything and get ahead of myself. So with this as being the process of how it moves through, let's think about, and I'm going to hop as I talk to the next slide. It's just kind of a cautionary tale here and talk a little bit about the downside to the models, which is typically known and technically is called an hallucination. And that's when you have created an image that, yes, it's comprised of all the pieces before it, but that doesn't make any sense. And this was posted, I like this one. It was posted on National Geographic. And of course, little baby eagles don't look like the adults. They have a different patterning altogether. But the AI doesn't know that. So it puts them together. So if you are generating something, and I mean, I think this should be the same as with any other information. If you're generating something and you're not certain of it, or if it's got a questionable pedigree, just note it to say where it's from. So let people know that you've had an hallucination. And now with this, before I jump into what can these models do? How good is the imagery coming onto them? We've been staying flat on the image center. I want to start to take us into immersive space. So they're starting to see the emergence of diffusion models, which is what this is. We're going to get to what's called NERF, which is geometry, in a second. Very, comparable to what we deal with CAD and things. But I'm going to click on this and I'll pull up this living room. So this is a 360-degree room generated just by text. And it looks nice until you start to zoom in and things and you realize that it's missing a leg over here, that this table wouldn't man. And because of the nature of where I said, like if you had said, I want curtains, or let's do an example right here. Yeah, so I want curtains, and it would have all these different curtains. So it would working its way. What kind of curtains did they want? Did they want formal, clean? So it ends up with this image of a curtain that fits within the space that you've drawn out in Firefly. But then when it goes to combine it with the rest of the room, it just kind of has to smear things, and because it's not geometry, it's just blending and diffusing blurred pixels, right? It's somewhere it had, when it started, it had a million pictures of a curtain that would fit in this shape, found the right one, stretched it, and went to paste it. And now it has to just smear it around and blend it into things. So things, see how the table edge lines up and now the curtains come down. So that's the kind of stuff you get. And that's what's called an hallucination in those, but they're improving quite fast. Now we're going to get, so let's jump to, we're going to get to nerve here in a second. I'm going to keep checking time. I'm nervous about, we're good. I want to make sure we get time to play. Okay. So this is I didn't take Midjourney, because Midjourney is, well, one of the type ones, but that's a subscription. So these are all trials. And I'm going to go ahead and try to zoom in on this. Okay. So what I'm testing here is I'm not testing just the model's ability to create a nice image, but its ability to understand, the ability to think a little bit about the knowledge. The reason I chose this is that in order to build good models, you have to understand what's called prompt engineering, how to talk to the model. And you'll see, and I don't know how to do that. I'm learning. You don't talk to it the same way you do notations. You have to reference like movies or things, have to understand that it's building upon data sets. In this case, this is a very historically famous person in Japanese culture. He comes from 1600. He was a real person. A book is written. It's a very long book. I'm currently reading the book, so I'm familiar with it. So the historical subject is good that you have a lot of diverse records to pull from to cross-check each other. So it's been a lot of different people have written about it, a lot of different sources, right? Just like journalism, check your sources. But the most important is the hallucination control, and that I am familiar with the person, and that's because I'm reading the book. Not that I'm an expert on anything, but so I can check, because the problem with this AI is that it can produce tons of information, more information than you've seen before, but it might be 95% accurate. And it becomes very difficult it's a different kind of editing. Instead of looking for misspelled words or obviously sentences that are clumsy, like you used to review a report for somebody, now it's a digits off, or it's not, Jim, it's Jack, and it's really small things. But zooming in really closely, you can see that it's a pretty similar to them all. I'm going to just point out some of them. This is Night Cafe. It's doing a good job. You can tell a lot of the AI models, and they're getting through it pretty quickly, so it's not anything, but functionality, things like hands, feet. It doesn't understand that a hand can't bend backwards. It doesn't know how the fingers operate. It's just seen the hand in different positions. It's never actually seen it operating. So watch for things like that. But it's a pretty good quality. It also tends to, but it's gotten the kimono, the top knot, the kimono. It has the two swords and everything. This is OpenAI doing. I should have started with Firefly. So most of us are using Firefly, and you can tell Firefly is not one of the most powerful models. You can see the person's got the sword out, but the sword's out of the scabbard. They're grabbing onto the blade. The hands are all, kind of messed up. The flooring is nice, perfect. It's some type of an interior floor from somewhere. We've got branches just growing out of the windows and things. So Firefly is definitely a just mashing things together form. If we go over back to OpenArt, a little bit better, but you'll notice that the swords have been attached to the rope. So in the process, when it was making this, and it's found a really nice sash, and it's got that sash on the person, and then now it's going to put a sword. It found the sword I want. using that same type of blur process. And it goes to put the sword on, doesn't know how to smear it, and it sees these two things like, oh, well, most of the time, if I have those, I connect them. So you can see the procedures, and that's the neural network. That's the mathematics, is how does it recognizing these things? How is it trained? But the face is very good. And then we go over to now this is I think yeah dolly. So we're getting pretty good here with dolly. The person's grabbing the sword, they're resting it. The scabbard looks like it's maybe they attached. See how the the handle is going the wrong way. So you're seeing that same type of thing. But okay, and then it gets down to stable diffusion. Very impressed with this one. Roads rough, swords are out. They have both the long and short, and it's done correctly. That the knot and everything is tied correctly. So it's pretty. As the models, the top ones that are producing on a per image basis are getting very good. So let me make sure I'm zoomed all the way out. Let's go to the next. So, but we like immersive. We like 3D. And what is the work that's going on with that? Well, the one of the issues we're facing right now, and we're familiar with it, and when we take an image and we want to process that image in Photoshop or something else, lighten it, blur it, change, especially if we change the dynamic range, highlight, shadows, curve, things like that, we'll end up with seams on the up, back, and downward cubic faces, right? The image wraps around, wraps if you're looking at the front, it wraps behind you. So the seam will be on the floor going up behind you so it goes from zenith back behind me down to deer will be the scene. And it used to be that you could do some Photoshop beta was handling 3D projection, but it dropped it out. The reason being is that to take a flat image, which is easy to work with, this flat grid, and turn it into into the cubic and handle this cubic, it becomes extra math, and the audience wasn't there for Photoshop to do that. You can still do 3D painting. They call it in painting in Affinity, but Affinity can't afford the models. Even Adobe isn't using or affording the biggest models. So you're still left with going back and forth between cubic and equirectangular, but I wouldn't worry about it. The reason is that the world is definitely this artificial is definitely going towards an immersive. It's we have augmented reality and things, and there's a lot of research underway to take us from the flat to the spherical. When you're looking, and if you really get into this, you're going to end up becoming a GitHub which a repository. You're going to get an account and you're going to find a lot of the cool research is coming out on GitHub. I'm just going to show that this is one of them. If you do, and you get to GitHub and you see these are PhD students doing research or projects that Adobe is working or Apple is working on. You'll find them before the algorithms are packaged into something, before you see them in DALL-E or whatever. You'll see the individual algorithms being tried out and tested, researched, put up for peer review, which means all the code is available to you in this GitHub. This one is, you can see the two researchers here, and I'll click on the GitHub repository in just a second to show you what it looks like. It's not that difficult to figure out. It is confusing, but this is a photograph from a camera of an office space, flat, and it's been seeded into this model, which is running on a dolly. So it's a model that's dolly is controlling dolly to do this. And it first takes that image and warps it, converts it into like a cubic face or whatever as you've seen. And then it extrapolates out the rest of the room and creates a seamless image. And I don't have this one. I've seen a couple, and they're the smearing, you can tell if I zoom in, they're mostly interested in kind of the edges and stuff. So they're not doing a whole lot of computational work on the couch here. They're just trying to get colors and tones and lines and things like that down. But it's kind of impressive work. And if I click on the link here, and in this presentation, anywhere you see this color is a link, this takes you to a standard GitHub repository. You'll see the contributors right here, the people who made it. Up here, you'll see the ability to clone it or to create a clone. Create a clone of what they're working on, this whole repository, onto your own machine. You can play with it. Maybe you found something else that you add to it. And then you can, if you come up with something cool, you can what's called fork, or you can send them back a copy so they can take that. So it's a really great way to do development work if you're starting to get into code. And then and all of these will always be a README right here, and just click on the README, and it'll take you to a description that writes that they're talking about what they're up to. I got a slow connection. Okay, so this is the pure living room that I showed you. Here's outdoor ones that they're doing. And here's, just stuff where they're seating from a single shot. They're seating. That's the office. But here's an interior one. But GitHub is an interesting place to do research. Okay, so now the cubic and equirectangular, we have the tools, the diffusion models to work in planar 2D version. That's Firefly, taking into Photoshop, things like that. And you can do a lot of work with that. I gotta get the link out of the way. Okay. So this is a panorama in a office space. Let's say this is an application for construction. And these are a before after. They're sitting side by side. I'm going to go ahead and shift it. I think it looks better in the split screen. So if I take it to split screen, you'll see, I'm going to go to the left, that I'm using by taking the equirectangular image, pulling it into Photoshop. You can use the offset. So if you've unwrapped the flat image and you brought it into Photoshop, if it's seamless, you can shift it using vertical and horizontal offsets. So the planar area that you want to go into Firefly, and in this case, you're just using the new remove tool. And then I'm adding, so these are pulled out using the remove tool. These are just thrown in by, hey, put something in. And you can see, I'm going to show you the smashing. This will show you how we're using a diffusion model, not a NeRF model. I don't have geometry. I'm just mashing and blurring pixels around. This beam, as it goes to remove the things, it doesn't have the intelligence to know that beam has to go back in. So it just kind of blurs it out. And you can see there's some approximation where it's blurring it to the radius of whatever. There'd be some mathematics in there that's telling it how, in this case, to make that. Does a good job over here. I start to put things in. It's smart enough to know to put something behind the beam, but it's adding a specular in to the beam because of the light that's behind me, but that's not really what I wanted. It's still very good though. Putting cans in. It knows, now I had it clean up some of the trash in this room. It knows to put the ladder in, but you'll notice if you look closely, it is changing the shadows. So it's not, if you thought that it was leaving the other pixels and just putting yours in, that's not what it's doing. If you draw the selection and have it replaced, it is replacing all of those pixels. If you're working, I don't know what the limit is, but I know on some 22K resolutions, if I'm looking at carpet that has a certain pattern to it, the same WAR patterns or the messes up you'll run into problems with that. But I'm not going to cover a generative fill or techniques for how to do that. I'm assuming, there's all different ways. Everybody has different techniques. So this is just kind of showing a split view where, again, you can clean the space. I could come through and start to paint the walls or have it put, you could build the room out doing that diffuse model, but you'd still end up with a mashed geometry. So let's go to the geometry side of AI, which is similar to photogrammetry, right? So but it's not photogrammetry, but it's using AI to kind of make photogrammetry. This is a fun one right here, Skybox. You may have heard of them, but Skybox is the environment, the sphere that wraps around a video game when you're making, so you'll create video game environments and you can create them interior, exterior. I'm going to go ahead and show you the exterior one to start with. Now I'm using the free version here, so I was pretty limited, but and you can see kind of the prompt in its street view in dystopian city ruins, crumbling brick buildings with graffiti, wet streets, overgrown socks, trash, dim street lights, bright sunny day. And it actually will take that prompt and then convert it to cinematographic terms, shallow focus, things like that. But this is now an environment that I'm in, and it's pretty good quality. You can see that it's diffusion model if you zoom in and just zoom into where corners meet or where objects meet up, and you'll start to see that things don't make sense. But from a distance, it's pretty good. Now it's diffusion model, but it's also creating geometry. So it's kind of a mix. You'll see a little bit of a mixture where it'll create the diffusion geometry and then extract some geometry out from that. And in this case, you can download the 3D geometry for this. You can download this as a light box to be placed into a video game. So if I was making a video game and I was having a fight scene here or something, this would be an environment I could have it walk down the street, create at the next spot. So very powerful and fairly realistic. And you just type in whatever you want. It takes it a while to do it, so I don't want to create that. Let me show you the interior version so you can do ones on the inside as well. So and this is this modern art gallery. Just left it to do what it wanted. So I was pretty impressed with this one, just cranking this out. So this would have geometry associated with it that I'd be able to download and move this into a Unity engine and create a video game with this being, I think so I could move to that spot, create something else, build this out. You have the ability to build off of patterns also. So I've been showing you everything right now is just make something, but you can do kind of like a motion capture. You could draw poses, a rough sketch of where you want the person to be in a scene and how you want them to be, and the person will. So you can draw your keyframes in sketch mode for something like this as well. And but you don't see the geometry in this because you can't download it. So let me move to. Okay. So now we're going to get into. So that was a mixture that used a little bit of diffusion, a little bit of nerf, but let me get into pure nerf. And again, I'm going to hop to. So this is this is a GitHub. So I'd have to go to this GitHub repository to use this code. It doesn't reside in the interface yet, but I'm going to go ahead and zoom in so you can see what's going on here. And what's been done is this is the output. I have it kind of backwards. They took a 360 cameras, the handheld Insta360. In fact, I'm going to probably see if I can't. I sold all mine because I've been using high-end DSLRs, and I know that they've reached up in quality, but I still do museums. But what my camera can't do is you can take the thing on a stick and think of yourself collecting a point cloud like the camera. Well, the camera is a laser scanner for you. And they have some really cool videos. Just type in Insta360 and Nerf models, things like that, and you'll start to see this. And I'm going to show you a drop where you just take a video and drop the video and it makes geometry. But in this case, they take the video and they walked all over the front of this building to collect a data cloud. And then the interface on the right is a Unity, and they're showing them just creating a camera path that they can then go through. So because they have geometry with textures mapped on it with Spectator as well. So you just take your Insta360, wander around, make sure you take a picture of everything. You have to have camera lock on, which is done automatically within Insta360. So that's good. And you want to keep yourself off of the main lens, which most people do anyway. And there's some really cool examples where they had a car open with the two windows open. They have a person sitting in the driver's side. They have a stick that's gone all the way through the car, and they pull the Insta360 through the car. with the lens facing forward and back. So the seams would, if there was one, would be top and bottom. And they're able to capture the entire geometry of the car. They load it into these models and they go back in and they're able to sit in the other version or move around within the car. So it's pretty impressive. And I'm going to go ahead and just quit this and show you now. This is um, I'll jump back to Luma is one that's doing this. Luma also makes videos, the text to videos, but I'm going to just type on this one here so you can see the geometry. This was just my little beach cruiser. It's a 1965 Schwinn, great bike, but it's kind of I call it my mobile exercise bike because it's so heavy, but it's like an exercise bike, but you still go somewhere. All I did was to take my cell phone and you want to shoot on diffuse days. Shadows could cause the same problem. So if you shoot in high light, the shadow that's moving across the ground, you're using image recognition, it gets confused by the shadow. It might put it in. If you're taking a 360 camera and you were to walk through this scene, and if you are getting yourself into it, you might get like a point cloud mess that goes. But so that was just auto running, and I'm going to go ahead and zoom in. You can see I'm looking at I'm in a piece of geometry. If I go underneath it, you can see, kind of an unusual nature, but it's capturing roughly the blades of grass. If I zoom in, I'm picking up spokes, and you'll notice it's picking up the specular, the highlights, which typically you would have to map on in CAD or something else. If you're using a scanner, it's capturing the motion data, but then you got to go in and put on some type of a specular map to get these reflections, and it captures them. But it's pretty impressive, and it's doing some of the surrounding. I could have walked around and captured things. If I had a drone, I could have done something. To show you what they're doing with drones. And, man, I'm like, makes me want to go get a drone really bad. This one is this. Yeah, Explore Creations. So these are all people doing things, standing, people are coming around, they're doing airplanes. And we've seen this technology before. We've been doing, okay, here's this is a really cool one. This is a nice one. So pretty nice for they ran a drone around. Now I can't, you're going, in this case, you're going around the center. That's a limitation of the viewer that I'm using, right? They've locked a nodal point on the image and then I'm just moving around it. But you can have other ones where you can zoom in and see. So you can see there's but it's a nice quality. Close that out. Okay. And all right, I'm going to try to wrap up. I got 15 minutes left, so I want to get into that's kind of the image stuff. So I went from flat. We have the image sensor off the camera that we're familiar with, collecting a grid of data and then processing it neural networks, and then we're able to make all of this geometry. But the content that we create, we still have to place it into an interface, do something, create buttons that do things. The area, I'm very impressed with what the AI can do to help you in coding, and things that it can help you with that I've been playing with is outright generation. So you can ask it to create a print statement in Python, and it cranks it out. So little snippets like that. Uh, you can have it do more advanced functions. The completion, if you're working in one of the big editors, I think I've included them on here somewhere, but the Visual Studio, things like that, it'll start to understand, and it autofills, just like if you're typing in your name into an email, except it starts to, if you type a function, it's got the opening and closing brackets. If you type an if, it has all the increment counters and everything start to pop up. Does a great job on review of looking at code that you write. I was kind of surprised. I dumped in some code that I thought was pretty good code, and it came back with a lot of good recommendations on how to improve the code, and they were accurate. This is an area where I think because it's coming out of computer science, the model seemed to be trained quite well on computer science, so it's doing well. The debugging, again, I kind of review and debugging to me are the same. And then documentation, this is a pretty neat one. I work with KRPano. A lot of times I'll produce a virtual tour and the client will want to know how to have a manual or get some guidance on it. What if I want to update the hotspots and things? And in the past, I end up having to write manuals, and it becomes kind of a large part of the project, a finishing touch. And it's really not something fun to do either. You've handed the project, you're done with it, it's up, it's running, and now you've got this logistics products to produce. And boy, does it can just crank a manual out better than anything I've ever produced in an instant and customized to individual report. So let's go to, I want to just show you, oh, good, at the bottom, I got the auto. If you're really into programming, go look at GitHub Copilot and the other ones. So this is an example of, let me try to move the Zoom bar out of the way. So this is an example of just a snippet of code that I've written. It's coming out of a KRPano, and I'll do scenes, but I don't write a whole lot of comments in there. If I hand this over to somebody else, they don't know what it is. So I write this, you're seeing the prompt here. I made it for a client, they're new to code, throw a whole bunch of comments in there. And how you ask the AI is kind of the difficult part of here. So you can see it's come back and it knows all the way down to that I'm using a map. I'm opening a map. It understands what the thumbnails and low res previews. And I've been training this model. So this is a chat GP. Sorry, this is a Gemini Studio model, and I've fed it like all of the KRPano documentation, a whole bunch of books on XML, structure programming, everything I could find about virtual tours. And so I've slowly been training it to, hey, this thing with a circle on top and the squarish thing underneath is a tree. That I've been doing that with this and training it slowly so it understands. And then look at it, beautiful comments. Typed them all in. So I could hand this over to a client and they would basic programming skills, they'd be able to understand this. Now, that's not what I want to deploy. A lot of times I wouldn't put the comments in because I didn't want to have to pull them out. I didn't want to maintain my code or things started to. But I also would publish the first one that I showed you. I wouldn't minify it because if you minify your code, sometimes it can cause problems. I was running this back and forth between the stuff I wrote, fully commented with all kinds of hand holding in it, to minified back and forth between the two and never had any problems. I could load this in and run it, take something, tens of thousands of lines of code, hand it to it, maybe 20% reduction in size, and it works just perfectly, and pull it back the other way. And I'm doing that in ChatGPT. Imagine that if I'm in, because I'm not using Studio right now, but imagine if I'm in one of the true IDEs, integrated development environments, where they're not just programming. I imagine they're extremely powerful right now. This is create a comprehensive manual. I'm just showing you an excerpt. I think it might have done maybe 20 pages, and it's referencing the actual lines of code. If you need to update the map, go to this file, line 32. You'll see, change the something.png to whatever. Remember to use the PNG because this map has a transparency. Pretty impressive. This now, the last, I think we're kind of getting good. I got like 10 minutes left, and maybe we can watch the asteroids thing here. The last thing I'm doing with is the dream of, KRPano, beautiful player, makes really wonderful stuff, incredibly versatile, but it's a pain to learn. There's not an interface on the front of it. You got to do that. Could the AI be could I train it to the level that it can do the following? And it's getting close, but this would be, and as you talk to this, I'm learning, you don't talk, I keep finding myself saying, please, can you please, please issue that as a PDF. And so it's not the same. You're talking to a tool and you can use notation and scripting. So this I'm trying to work with is telling it to create a KRPano virtual tour. I want 30 of them. They're going to be 8K panos. The naming sequence is going to be 001-tiles. So the 30 will go 001 to 30. I'm going to use an upper right map. and it would know that the map I'm going to be using is floor.png. I want within the scenes, I want three navigation arrows spread at 120. So when I go into a scene, I'm usually going to be seeing the arrow, and then I can move the arrow to where it goes. My guess is that eventually I would be able to feed it a floor plan, tell it where I'm choosing. I don't think it'll ever be able to if I feed it a floor plan and tell it, you know, tell me where the best spots are, because it doesn't know oh, well, that's the bathroom. Why'd you, I don't want to look at a toilet. So I think you still would have to do that creativity, that design. But I think we get to the point where the design process of the virtual tour is the clients give me the floor plan. They've told me what's important and what they want out of this, and I know about where to go. And I put little dots on the floor plan and I hand it to it. I go take the pictures. We're not going to have time to show you. I can show you where you can use when PT GUI stitches, it'll show you the seam line where it's actually blending the images across. You can use that image in Photoshop to point out, to look along there to see if it finds any mismatches, and then you can paint that area. So there are going to be ways to do automatic stitching or error correction, but in this case, it's just going to spread the arrows out and not. But I imagine you could eventually, like, it knows to put an arrow and point it that way because that's a doorway, things like that. And then I just have it include the functionality, which is I'm doing kind of an object oriented approach here. Everything's black boxed. So the skin that I develop can be applied to any analytics to track it. If it's bringing in the handlers for audio, video, text is its own file, its own, functionality. If I'm going to edit it, if that what the initial view is, things like that. And then if I want accessibility, I it's too long, so I type in 508, and then you turn and it'll ask you for the files, you give it the files, and boom, here's this virtual tour. And would you be at the point where oh, I said I got unstable internet connection there. Hopefully you guys are still hearing me. Hey, Lauren. Hey, one of the board members, am I still on?
Yeah, you're back now.
Okay. Oh, how long was I gone for?
Half a minute.
Oh, okay, cool. Okay. Well, so I'm at the end. I got like 5 minutes left over. I wanted to show you.
Lauren, if you go a couple minutes past the hour, I don't think anyone will object.
Oh, okay. Yeah. So I'm gonna show you. Dun, 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 dun. I downloaded so much stuff. Okay, this is from my friend Candace Sergio. I got her name there, and she's been playing with this. She's really big into theater. She's a lawyer, so she's good at cameras and good at image processing. No background in CAD or computer science, things like that. And she's always been talking about, oh, you could make this, whenever I've known her for a long time. Whenever I'd tell her about things I'm working on, she would always extend off of that and like, oh, you could do the following, you could do this or that. This is Luma, and it allows you to create 5 seconds at a time, cloud-based. And so you'll create the scene and then you start to animate it. And I'm going to go ahead and put it into full thing, and I'll hit play. So this is the new text to video. And you'll notice, like I said, things that are soft, where the water looks great, where the rocks are going to the water looks wonderful. Things, and you can see where it stopped, if you look at our hands, things that require thinking, intelligence, like how the pagoda's put together or things like that. It's not figuring that out yet, but it will. There'll be new patterns where you'll start to put like, hey, if you see this object, here's some new rules or new things. Then you're back to that neural network where you're just tracking all of this data. Um, I think I might go a couple minutes over. I'll see if I did save. No, I thought I had one where I was showing the stitch. I wanted to show the stitching, but I don't know if I saved that. Processing. Yeah, here it is. Stitch error detection. All right. So when you're one of the things, this will be a little trip for you for generative fill, and this is kind of you're probably all going to tell me that you do this already, but I found this and this was a huge time savings for me. So if you're in PT, so this is the underlying image that I've stitched, a just current ongoing project, and the PT GUI does have somewhat of a thinking in it, but not there yet. You'll notice, and these red images are the seam lines. I just take a screenshot of the panoramic editor that's showing the seam lines, take that and I'll pull it into Photoshop, stretch it out, roughly stick it over the top of it, and I can really quickly see if I've got any problems where, and I'm interested in text because it's again, it's smearing things together. So that's okay. That's going to be a little bit of an issue. This is no good, right? So I can look at that and know that I'm going to have a problem there because it's going through something of detail. And I turn the seam off, and sure enough, there's the issue. But let me show you a way in which I'm going to pull up an image that's currently in production. It's a real mess. Yeah, this is it. I'm going to leave it in equirectangular format, but typically you edit in cubic. So this is one where I'm missing the ceiling. That's not a big deal, but I've got a really nasty lens flare going on. Here, let me jump to, well, kind of a mess here. So I got a really nasty lens flare going on here. And I would like to use the J. Some of these I use a content aware because it's a lot faster. But if I'm using the new AI, I'm on using Photoshop beta, basically it's called in painting. All right. So I paint this and then if I want to go to the next, I got to sit here and wait, right? You can see the waiting and waiting. Man, I got a bad internet connection, so I'm really having to wait. Uh-oh. I wonder if my internet. Can you still hear me?
Yes, we
And
can
we
hear
hear
you.
you.
Okay, I don't know why it dropped. Okay, let me I don't know why it froze up on me. Okay, that doesn't matter. You get the point that if I go through and click each one of these and wait, it's wait, click, wait, click, wait, click, wait. And I don't know if you do this. Sorry, the zoom window is just, I'm on a 13-inch screen, and so I'm having a little bit of a problem with the zoom. Okay, so let me take and flatten this image down. I should have done that. Sorry. Okay, so flatten the image. That's what the problem was. So if I click on this, right, so I'd have to wait if I'm painting these out. Click, wait. So here's what I do. And I'm sorry about this. My monitor is just a mess. I take and create a new layer. Above that layer, I go to a brush mode, and I usually it doesn't matter, but I'll pick black. And then I haven't played around with the transparencies, or sorry, the feathering. I don't know if it matters too much and edging, but I'll just do that. And then I'll usually switch to F mode so it's nice and comfortable. And I'll just go through and I'm on that layer. So I'll take and paint out everything. Yeah, usually I like to use a bright color that you can see. So I'll go through, it doesn't matter, and I'll just go and paint out all the stuff. If I had that seam, the seam line, some of these you can do, some you can't. You don't want to do more of a guided fill, but you get the point. I'd go through here and I'd paint all of my errors. Right. Then I'd come back to this and I'd hit Command. You'll notice that when I hit Command and then select it, I've picked all of that. Then I switch to the layer I want to work on, move over to J, usually just bring the brush up or zoom out and click and just scrub over all of those. Then it'll do its little thing, remove. God, this zoom is right in the way. You get the point. If I zoom in now, turn off that layer, it's fixed all of them throughout the image. And I can just, if I want to check stuff, I can go in and check to see how did it do in that area. So that's rather than, so you paint the image first, all of the errors out, and then just one big giant thing's not AI each one, but that's it. Oh, all right. That is it for me. Let's open it up to.
Lauren, there's a question in the chat from Brian. If you can generate a 3D model from an existing 360 equirectangular.
Yes. Yeah, that would be well, no. You would have to have more than one equirectangular. To do the model, it's just as if you were using a laser scanner. You'd have to have a lot of data points around. Let's see. I lost my.
Laura, I think the more applicable question would be, you showed an example of taking a video camera, moving it through a space, and thereby generating point cloud to create a 3D model.
Yeah, that's roughly what they're doing.
Right.
The terminology is a bit off.
Sure. What if we were to do several, high resolution 360 images within a space, and then can you just combine those to get a real high resolution and precise modeling of a room, say?
You can, but I've been doing some practice. You have to take a lot of image. I've done that before, unless it's a flat planar, like a hallway or something in like a modern art gallery. You really need a lot more image data. You end up with lots of holes in between the geometry. I've actually done here. I can show you one that kind of shows this is done by photogrammetry, just off of the images itself. And so I'm in a space, but you can see as I start to move and it rips. If I go to the dollhouse mode, you can see how much is missing of the model. And that was trying to recreate the geometry just from, and I had taken here, the standard kind of Google spacing of maybe a meter apart, and it still broke. And it's for the geometry, the Insta360 seemed to be doing a pretty good job, and they were just, wandering later Insta360, and so it wasn't like, oh, you set it up, sit back and take a button. No, they were, walking in a room, going underneath table, just because they're collecting. Of course, there's a way and there's tons of YouTube videos on it. But then you take that video and you upload that video to the Luma, which, so here this might be the video. Yeah, there's a lot to these guys. There's the video one, high quality images, but they have a modeling one, and this modeling one is perfect for the 360. And you just create that movie, right? You scan your one and you upload the movie, and then a couple hours later you come back and here's this mesh cloud that you download, and it has, in their case, they're downloading, they have a player that's how they're displaying it. But that model, if you're using Unity, you would bring that 3D model into Unity as
I added the link for you for the Luma API for the 3D, the video to 3D model API.
Thank you.
Mhm.
Yeah, it's a pretty cool one. So yeah, you are downloading geometry, and that's the gaming world. We have we keep kind of getting closer and closer to the gaming. They get more and more photorealistic. They're starting to use our tools. They're starting to import our panoramas as environments, and we're starting to kind of run out of power, starting to want to move around. We're starting to Matterport. We're creating more and more geometry that we move around. So we want that 6 degrees of freedom. So, any other questions or?
Several. First of all, having to do with resolution. When you create these models in the way that you have, the examples that you've given here, let's say an image is shot from close to part of the scene, that would be fairly high resolution there. When you match it in with all the other ones, do you lose that resolution, or when you walk up close to that object within the scene, does the resolution that was caught by the closest camera, is that maintained?
No, it's we're still lacking the processing power to handle highly detailed point clouds. And I looked a little bit into this because there's a lot of wow factor and, oh, this is amazing, and you can take your bike and download it, but the models are not as good of quality models as we're seeing with the laser scanners, and that kind of makes sense. So there's still point clouds that you end up with, and there's a lot of editing, a lot of holes, and the mesh degradation, things like that. And so yeah, you could do some experimenting pretty quick to find out how far away you've got to be. That's probably the way to look at it. How far away do you have to be from something for it to still look real? Because I haven't seen the only stuff that looks real is what they call procedural modeling, the TrueCAD, where it's made mathematically and sharp edges. The organic, which we're typically doing, is artisty artsy from a distance. But they're getting there. Everything is just a matter of scale. The mathematics are a little bit different, but it's still linear algebra, just handling massive, which is why they're building data centers and tons of data centers. And I forget what ChatGPT its user base is, but they have a lot of money. I read an article that it took 30 million or more just in electricity alone to power the machines that built the model, let alone training it. So yeah, pretty cool stuff. Any other questions, or you got more?
I'm going to toss something at you right now. I wish I'd warned you. In the past, you have said something to the effect of either you learn how to use AI in your business, or you will be left in the dust. Could you give, and we've seen a ton of data here or information that justifies that, but could you give me the elevator pitch of why do I have to learn AI, or I will
you know
not
what? I would after doing this month of studying it, I would change that to say, if you don't know how, you don't need to learn AI, you need to learn how to use it, how to apply it. In fact, I would not learn AI. I saw some pretty disturbing YouTube videos where they're talking about the code. There's a lot of money and a lot of work in the code generation and the training, the tools to build, to work as entry-level computer science programmers, writing functions and being handed a code, and they got to go off and write this function and do these things. And this is a professor, and he's giving this talk about code. And let's while we're doing here, let me pull the presentation up. We can watch. You can see what this last one. This one's the scary. This is where you're going to, if AI is going to turn on you, this is it. So I'll just let it start to run up.
Things that I'm dancing and dots, and I made them into a successful
business.
business.
This is really cool. Okay. So I'm going to go ahead and take it into things, and you'll just see as they're doing it. So this is Codex. GitHub has Copilot. So it's found an image off the web. It's just adding it. You're going to see Python script being written off to the side here. And he's just pointing out that code segment, make it smaller. And if you've seen coding, you'll see on the side here, it's make it smaller, puts the comment in, changes the size. So he'll keep going through, but I would learn, don't spend, that's why I purposely today did not spend any time in what machine learning is, what neural networks, what's Gaussian splatting versus, that's SIGGRAPH, that's computer science folks, who cares? It's a black box. You don't care how the camera works. Well, you need to know a little bit about the camera, where the knobs are, but you don't care, well, how they made the glass or whatever. And learn the applications of it. And I think our community here is why that's so powerful, is because you can talk to the best AI experts in the world, see all kinds of YouTube videos on it, but nobody's told you how to edit within spherical space for a panorama. We're, as a professional organization specializing on content creation, we're the ones that have to have webinars like this and figure out and tell others. I love the idea of, I produce these virtual tours, being able to hand a printed out, or just not printed out, but a really nice PDF that it's 20, 30 pages and it's just a click of a button, and I hand that along with the customer. That adds value to, hey, here's your virtual tour. By the way, here's the manual for how to run it. And if you have any troubleshooting, just here's the troubleshooting section. It's a nice touch. I didn't get, there's a lot to pack in here, but the design stuff was pretty impressive too. The engines can't read JavaScript very well, so it couldn't just take a Pano Tour Pro or a Pano 2 VR 3D Vista Tour and put it in a folder and hand it to it and say, how can I make this better? It's not there yet because it can't understand the interrelations. But this, I was surprised with. You can take a screenshot of your interface, hand it to it, maybe tell it, I've got 3 colors I'm currently using and I need a 4th. Give me suggestions for a 4th color that would be complementary and somewhat in line with today's trends and themes. And boom, it tells you. So it's very good at that. And you can kind of see right? So I don't see why this is writing Python. I don't see why we wouldn't eventually have this type of an interface as well, for not anytime soon, but for building the virtual tours. Most of what is going on in a virtual tour is the same mathematics. It integrates very nicely with what we're doing. So I'd say, yeah. You can see, pretty impressed. So you can see that this person just keeps typing in and just keeps building the game, and that this could be exported out as a as a native app. So the process is definitely changing to where, if you are going into computer science to learn, like going and getting a Google certificate to be certified on Google Analytics with emphasis in report generation, which is what I did. Let me show you. Let me quit this one. Let me quit this. Okay, we still got time, right? So let's do Chat GPT. And I want to give it, let's see. Dun, dun, dun. Data analysis. I'm going to hand it. This should just be a dump of data from the Natural History Museum. They let me use the analytics data sometimes, and just to make sure that I'm looking at the right thing. Yeah. Oh, I got it backwards. Okay, so this is just a raw dump of visit user data, it's got some empty columns. The columns are messed up. You typically wouldn't, you wouldn't be able to make much sense of this unless you clean the data up or whatever. And I just say, tell me about this. So let me hide the things. I need to get a second monitor. So it's a report from a virtual tour. It's focusing on user engagement. Tell me highlights issues with any scene in that tour. So it's telling me it's going down. I mean, it's all these different scenes. It's coming down and telling me I've got high interaction with this scene. I've got good engagement issues. So here's an issue. So artwork, yeah. And that's true. I know why that is the artwork was, we only had one little piece of artwork we added, but it was never talked about. It was never introduced. We're going to have artwork. And so when people see the artwork, they tend to not know what it is and they don't go on. Because people who are finding it are just finding it, not necessarily looking for art. And the people who would like art don't necessarily know that it's there. So I've already gone through this, but it goes through and is identifying the data for us. So if you set up Google Analytics on your data and you would have gone, spent your time and got a Google certification for report generating and analysis. In fact, I was going to, when we did that Google Analytics maybe 4 or 5 months ago, and I'd planned on doing a follow-up thing on how to use the Google reports. In fact, I'd started getting certified in Google Analytic reports and generation, thinking like, oh, that's the, you get the data hooked up, but understanding the data, that's where the real go learn how to make sense of Google Analytics data. And now I guess you just dump the data and you ask ChatGPT, hey, what's wrong with my website? It's kind of different. Any other questions? I don't want to ramble on too much because I had a lot of fun at this. I would say go, like I said, everything's in that PDF of the meeting. All the links are free. So go, and I don't want to get anybody hooked up on pay subscriptions, but go play with them, the Skybox AI, Luma. If you are familiar with GitHub, you know how to use it. Take a look at SIGGRAPH proceedings for last year. There's a lot of work in this area. One last thing is that something to watch for is that because the models are trained on existing images, they reinforce what we currently have. Most of the images are flat. So, there's not a whole lot of 360 images that have been created or pulled in, and it takes some understanding of how they work. So understand that if you're using the painting programs, that they've been trained on flat 2D images. So if you try to paint a stitched line on an equirectangular image and you've got curvature or the couch or the things are distorted and you're trying to put back in something else, the model's been trained on planar geometry, not this distorted stuff. It'll take some time, but you can take the 360 scene, shift the panorama to where you want to put a couch or you have some empty space. That's how I did that staging in the construction area. Convert it to cubic faces because an equirectangular image is spherical. So it can be shifted. You can resettle it. It's fine. So you can take it and rotate it to look at something. Just because the cubic face, the up, down, whatever, isn't lining up with what you want, you use off shift to do that. Pull it into the diffusion modeler, add couches, whatever you want. Save, as long as it doesn't extend off of that cubic face, you're good. Put it back into equirectangular, and that's how you add stuff in, by staging. I'm going to check the chat real quick. PDF's been thrown up again. All right.
And
looks like you were all experts in AI, weren't you? Or you're like, what is he talking about? Just when you go look at it, don't try to learn it. no sense learning how AI. Just accept it. AI is your friend. Nothing bad can happen with it. I feel pretty good about that. That this has been hype. In fact,
Art,
I think I'm going to start the Umbrella Corporation. I'm going to go see if that URL is available. It's a nod to Resident Evil, by the way.
all right. So you're saying that we do not fear AI, embrace it as your friend.
Understand that what AI is a synthesis and a prediction based upon everything that we've done and have right now. If you're pretty happy with how things are going, how our culture is, how how we interact, then by all means, more of the same. Now, that's the part of the predictive part of AI. It's not it's predicting off of everything we've taught it. So, for example, most of the models have a cultural leaning or bias built into them towards North America, simply because the bulk or a lot more of the information that was digitized and put in there was coming from North America. The models are developed in California, so it's a little bit more information centric to them, which is why for that thing of choosing the you can do examples of it. My friend had a good one. She said, you can ask, okay, so she was using Christopher Walken, and there's a movie, I forget, where Christopher Walken does this very iconic dance, but he doesn't dance because it's Christopher Walken, so he doesn't dance in any other movies. So if you ask, that's the only Christopher Walken dancing that we've got. So if you do something with Christopher Walken and you put a little bit of dancing, that piece of information is so powerful that you're always going to get you're always going to get that dance, nothing else. It won't do anything else. So if that piece, maybe it was Elaine from Seinfeld, and that's the dance. When you don't want that dance, the legs, but that's what the information is. So unless you put some bias or control in there to say, hey, don't use this kernel, and it could be something as simple, and they're trying, like, don't use this racism, this terminology right here, this historical record that it happened all the blackface, right? This blackface has occurred. I got all kinds of it occurring in historical records, but that's not good. Don't use that in what you're going to generate. That's an obvious one, but there's a lot of subtle ones. So who's training the model to tell it, hey, we don't do that anymore, or you can't, so it's like it's just it doesn't change, it doesn't predict, and so I think it will cause us some problems as we move forward. I think the problem, though, that it'll cause is the disruption in the employment and the workforce. There are a lot of jobs at the lower or kind of worker bee jobs that are going to be changed or supplanted, or it's the word processor coming to make the typewriter. So if you're working on typewriters right now, and that's all, you better start learning about. That's kind of where I would see AI, and it's wonderful. I'm obviously the generative fill, not painting out tripods anymore. What a wonderful thing that is to do that. So no, I don't fear AI, but I'm sure it'll cause some problems.
I'll give an example from years ago when computers were first coming into existence or use within the design field. There was one agency that I worked with, and the sales rep was talking about, lamenting that this was happening because it meant that so much of the handwork of design that he had been selling, that the rote kind of stuff of assembling things, was going away because it was being replaced by what could be done by computer. And he was saying, it's taking away so much of the billable hours that I can produce. And my comment was, well, what would you rather be doing? The boring stuff or the creative stuff? So embrace that capability and move on to doing what you really want to do, not the stuff that is just boring.
Yeah. I had the analogy of when I first got into photography, which isn't that long ago, there was a lot of people, they would always say, this picture is in camera. I didn't touch it, took it, and I know that these were people that had come from slide and that if you didn't get the picture, boom, perfect on the slide, it didn't work. So I understood what they were saying that, like, oh, it's in camera, but the camera has a computer. And they would have said, in camera, I didn't touch it with any computer. I'm like, but your camera is a computer and it has sharpening, blur, and the rest of that. So it didn't make, so I'd kind of like, yeah, whatever. They had the, get off my lawn kind of an aspect to it. I never would have thought, and I'm a wildlife photographer and I have a Facebook page. I never would have imagined that you would come to me and say, hey, guess what? There's a whole new way to do wildlife photography. And I'm like, oh, what's that? And it's like, you don't even use a camera. You don't even have to go outside. You just sit in front of a desk and you take pictures of nature that way. And I'm like, what? What are you talking about? And I'm like, take pictures. But that's the AI. And there's some people, like the person who made that eagle with the little eagles, oh, they're happiest. They love that. And everybody else was, oh my gosh, that's the most beautiful. I've never seen such a beautiful picture of the little baby eagles and all this stuff. The only issue is that the person should mark it as AI. And I'm going to show you here. I get onto the night cafe. If I can, I guess I didn't have the link. The Night Cafe Studio. I thought this was a clever one in that you can put the chat away. It's like a cross between Facebook and art generation. They're not doing 360 yet, but you go to, so you get credits. And if you comment on other people's stuff, you get credits. If you like them, you get things. You have your creations. This is where I created I was just creating the samurai here. But this, and I could evolve it, but I published it. And then there's all these people that are writing comments about it and they're liking it. And where are those comments at? So yeah, there's this, they're trying to create a community around this AI art. I thought this was kind of a clever, because this is where, like, if you're trying to show art pictures on a National Geographic site that you've made in AI, people are just going to get upset with you. But if you're showing them on a site where other people are interested, so you can see the comments, love the style of this, you got talent, and I just did the two, but you can see other people are, I mean, it's pretty impressive stuff that people are creating through here. So these are the traditional, painters and cartoonists and the real artsy folks and they're loving it. And it's kind of a cool community. So this stuff does belong in a community, not on Facebook, I think. So any other questions or?
I'm just going to make one quick comment as we wrap this up, which is, as I've listened to this presentation, I know I've gotten a good part of what you've been saying, but going over it again, I'm going to pick up a ton of things that I missed the first time watching through. And I think that's true of anybody in a situation.
Yeah, I watched all these videos on AI, learn AI and beginners AI and they got it. It was like the scene out of Something About Mary where he's explaining the 8-minute abs and how wonderful. And then it's like, well, somebody comes along with 7-minute abs. And like 7-minute abs, no. And I think it was down to maybe 10 minutes. I saw a YouTube video. In 10 minutes, they're going to teach me AI and neural networking in 10 minutes, and I can turn that on double speed. 5 minutes is all it's going to take. And I tried to there's just no way, but I saw of that metaphor of that we understand projections. We understand the matrix, the cubic face. We understand that spherical. We break it down into 6 images, and we're handling each of those images individually. That when you move that cubic face, it's just RGB numbers that are being transformed in space, just matrix transformations. It's not, and all that happens is the reason they're building the data centers is they just keep scaling it up and scaling it up. And it's the pattern recognition along with the color when they started doing the cell phones and focusing on a person's face, which was at 20 years ago, and that of course came probably out of NSA algorithms and things. Those are neural network processing large chunks of data. It's the big data stuff, but it's still our realm. Whether the environment that you're looking at was coming off of a camera, or whether it was produced by a CAD program, or whether somebody scanned it in with Matterport, you're still going to arrange a certain number of scenes together. You're going to have a map, maybe, or arrows to get between them. And even if you go to full immersive, you're still going to have the same considerations of, back to the story of, how are we going to sell this house today? How are we going to move through the building? Are we going to show the kitchen? Are we going to move here and we start at the kitchen? Where are we going to go next? It doesn't really, that's the point of AI, is don't get hung up on the terminology. Just assume that it works. And at some point, you're going to write something, ChatGPT is going to get you in trouble, certain of it. You're going to send something out and you're going to get a call back. This is an outright lie. And you're going to be like, yeah, I'm sure it is.
You had some great examples of that when you tried to use AI to create what are the text explanations of some scenes that you had.
Yeah, it does a really good job at code, though. I'm impressed with if you have any code that you've written, hand it to it and ask it, hey, what do you think of this? It really shredded a piece of code that I've worked on that I've polished for years, maybe 5 years. It's my main interface, and I thought it was, and I've looked at the forums, and I thought it was, a perfect interface, and I gave it to it. It had about 5 things, memory leak type stuff. This is, you're using too much memory at this. You need to dump your memory out at this point, and yeah, it's really good at that. And I envision that you'll get a point where you could build a virtual tour by voice, but not for us. I think we already know enough about it that it's more powerful for us too. Yeah, because there's going to be dangers too using. I wouldn't rely on AI too much, because it's the same thing as a calculator versus math. Yes, you can add numbers together like crazy with a calculator, but if you don't understand what you're doing, then you'll never get to numerical analysis. You'll never understand how to set up or to model an equation that the computer can solve. So,
Okay.
anyway.
Well, this webinar has been recorded. It will be available on the IVRPA website in the webinar section. Once it is available online, we will be sending out an email notice to our entire list, including everyone who has seen this presentation or registered for it. And if you're a member, you can watch it again. Plus, there's a plethora of other presentations that are up there, which, similar to this, give you information that I think really applies to our area of creativity, and it'll be difficult to find it together in the way that we have put together here in any other location, such as YouTube videos. So with that,
one last thing is just, I
yes.
forgot to mention at the start, my contact information. Somebody has a question about an off topic. Absolutely. That's the whole point we're here, is to answer questions. So if you have any questions about this, or you read the presentation and you don't understand something that I said, use the IVRPA.org email is the best to get me at. But thank you everyone. I appreciated your time.
Okay, so with that, thank you so much, Lauren. This has been, again, an excellent presentation. Even though it's only scratching the surface, it has given me, at least, and I think most of us, so much information and background that we can use to move forward.
Yeah, we might do a follow-up where the geometry, some of the tools that we worked or whatever, this was such a high level survey that you know, there's some very specific applications that we could do in maybe the geometry or the photo. We could do something on photogrammetry, maybe where we look at how the Matterport and how we do photogrammetry with Blender, and then how we're using photogrammetry and how we might we'll probably visit this in more focused applications later.
And that will be interesting because one or two of the webinars that we have planned in the future actually do feature photogrammetry. But it'll be probably coming from the perspective of how it's been traditionally done. So it'd be interesting to see how AI and traditional interact or compare in creative photogrammetric environments.
Okay. Thank you, everyone.
Okay, thanks.